Hello, hello, and this is Muko. Okay. So, this is the move zeros problem. It is a leak code problem this time. I haven't seen it before, but I have seen something similar to it. But before that, um, so this is the umpire. So let's see. Uh, let me just look it over here. Okay. Let's ignore the code. Yeah. So we're given an integer array of called nums, and we're expected to move all the number zeros to the end of the list or array while maintaining the relative order of non-zero elements. And we're supposed to do this in place. Pretty sure. Wait, did he say this here? Yeah. It has to be in place, so we can't create a copy of the array because that would be pretty easy. You just do a list comprehension where you ignore the zeros really quickly. So you're just like, okay, if it's not zero, then we don't put it in there. And we just do a list comprehension. After that, just do a loop, which is kind of what I still did. But yeah. So that's what you're supposed to do. You're supposed to get an integer, a list of integers, and then all you're supposed to do is uh basically like a bubble system, like a bubble sort kind of. So you're supposed to have all the zeros bubble up without affecting the order of these non-zeros. So it's 1 3 12, 1 3 12. The constraints are that we have the length of the list is between 1 and 10,000. So we're never going to have a case where we have an empty list, thankfully. Otherwise we just have to have a base case, I guess, in that case. And the numbers inside of the list can be between -2 to the 31th power to 2 to the 31th power minus 1. So it's a pretty big number, but we shouldn't worry about overflow. I mean, we're coding this in Python too, so it's fine. And the follow-up is simply, can you minimize the total number of operations? So, when it comes to this problem, when I was thinking about it, it was like, okay, we want to like bubble up things to the right, the zeros, that's the element that we're looking for. This kind of reminds me of a problem I did before, which is called remove elements. And in remove elements, we kind of do the same thing, where we, it's a lot, the description is a lot more. Basically, all we're doing is we're given a list of numbers and a value that we want to remove from it. And we want to return the length of the numbers list after removing it. Right, I'm pretty sure that's what it was. Such as the first k elements of the numbers contain elements not equal to value. So yeah, and then return k. Yeah. So you want the length of numbers that do not include the value val. So what this essentially does is it like bubbles all of the things equal to value to the right, because we're kind of just ignoring it and replacing it with whatever number is on length currently. So we're incrementing length every time we find a non-val, a value not equal to the value we were given. And that causes it so that we like skip over those without incrementing length. So we'll come back to it to like swap or to make the value there equal to the current one whenever we find one that isn't equal to value. So those will get replaced, and then we'll just have a bunch of values in the right. So this is a pretty cool problem, and we're kind of doing the same thing here, just with zero. So that's when I started thinking about it. Well, not this solution. Let's go back to my first solution. So my first solution is just that, basically. So we have a non-zero index, which is like length over here. And then we're going to iterate through all of the numbers, or we're going to iterate through the length of numbers And then if numbers at I is not equal to 0, which means that it is a number that we're not really going to worry about, we're going to swap the current number we're on with the last non-zero index that we're supposed to be on. So I'm pretty sure what happens here is kind of like this non-zero index at the start will be the same as I, but after you find a 0, it's going to be behind or lagging behind. But because all of the numbers before I have already been handled, we can just ignore it, which is what we're kind of doing here. And we're just incrementing non-zero index plus 1 each time we have this. Otherwise, we're just incrementing I over time. And what happens here is we get to the last non-zero index. We have the last non-zero index here. Or I guess it would be the first 0 index, I'm pretty sure. I probably should have named it that. But yeah. This number won't actually be at the length of numbers yet. It'll be at what, like, the length of numbers minus the number of zeros. So because of that, we can just go from non-zero index to the length of numbers and just make it equal to 0 from there, incrementing it. So we're just putting zeros between non-zero index to the numbers. And this problem doesn't require that we return anything because it's supposed to be in place. So that's the solution that I got originally. And I mean, it worked pretty well, but this little follow-up made me think that maybe I could improve it. And that's when I realized that I could just not use 2 loops, because yeah, that's a little inefficient, because you basically have to loop through all of the numbers that are supposed to be 0 twice, which isn't that bad, but you know, you could minimize that. That's something you can minimize. So this second solution does that. I still think I probably should have named this better, but basically the same rules being played is just swapping them, swapping the 0 to the place that we had before. So this kind of like, rather than just replacing it, we're kind of actually swapping it in this case, which minimizes or which handles the zeros too, so you don't have to worry about handling zeros later. So that's the only difference, really. I mean, if we look at the code running in Python tutor, the number of steps is a bit lower. It's 54 here, but for the same code for the last solution was 67. So it's not that much of a difference, but it is still a difference. And I mean, if you look through it, as you can see, there's not that many zeros. At the start, there was like 4. But once you get to the end, you basically have none. But everything up to this is in place. Now we're just going to replace these 4 with zeros at this point. So we just go forward, 0, 0, and 0, and then that's it. But in this case, if we look at it, we're going through it and the zeros are moving together. Oh, all the way to the end. So it's not like, so like those are getting handled at the same time as we're moving everything to the left. So like they're both getting bubbled in the direction they're supposed to be. So this one's better because of that. You don't have to deal with the last few elements, which is supposed to be 0 afterwards. It's the only difference between them. So yeah, that's this problem, move zeros. I thought it was pretty cool. It's both solutions are O of n, but I guess this would be like O of n plus k, where k is the number of zeros that are in the list, because you had to iterate through it again one more time from that range of numbers. But in this one you don't have to, so it's just O of n. And then both of them are constant space because you kind of weren't allowed to create a new array. So yeah, that's pretty much it. That's pretty cool.